Hi everyone, are you able to hear me clearly and see my screen clearly? Great, great. So the session is going to be for 3 hours. So first of all, welcome to a 3-hour session on big data with Hadoop and Spark. The duration of session is 3 hours. The agenda is that we will do the big data introduction in the beginning, and then we'll take a 10 minutes break. And afterwards, we will go over the architecture of Spark and Hadoop. And afterwards, we are going to do hands-on with CloudX Lab. If you want, you can go ahead and take a sign up for the CloudX Lab. That'll make your life easy when we do the demo, so that you can do the demo together. Also, please introduce yourself using the chat window while others are joining. This session is being recorded, and the recordings along with the presentation, this presentation, will be shared with all of you. This is the first session of our usual courses on big data with Hadoop and Spark, the entire specialization. Generally, this session suffices as the introduction to the technology stack. Okay, so generally, if you are from non-technology background and you're looking for an overview, generally today's session is sufficient for you. This session is mostly theoretical, and probably this is the only session which is so theoretical out of all our sessions. The reason is that this session has been designed for all kinds of audience from all kinds of background, so that everybody can get overview of what is big data. All right. The second half is going to be a little bit more technical, and then we'll do the hands-on. The first half is going to be a bit of understanding of big data, the definition, and other parts. So to ask question, you have to type the question because everyone except the instructor is muted. Otherwise, there would be a lot of noise. And I'll read out the questions before answering. So please keep your messages short, questions short, and avoid chat language, because I would love to answer every question possible. So it'll be great if you could keep the question very clear. It's okay to write longer questions, but not the chat language. I am really poor at chat language. All right, great. So once again, welcome to the first session on big data with Hadoop and Spark introduction. All right, let me just give me a second. Let me just check the audio. All right. All right. So I hope everybody is able to hear me clearly and see the screen clearly. All right. For questions, please use the Q&A window. Okay. It'll be very difficult to read the questions from the chat. Okay. A question from Sheshu is, any prerequisites to install anything? Not really, but if you have the subscription active for CloudX Lab, the second half, last 20 minutes, will be quite more fruitful to you. Okay, because we're going to do hands-on today, unlike our usual class sessions. Okay, so a question from Ankur. I wanted to ask you about internships. Is there any good internship available online to get certification in big data? You can drop an email to us at reaches@cloudxlab to know more about it. All right, great. All right. Let me just add my teammates. Okay. Yes, this session is being recorded and the recordings will be shared with you. All right. Great. Let me just mark all the questions as answered. Wonderful. Great to have all of you in the session again. So, all right, please use the Q&A window to ask questions. All right. The specialization on big data with Hadoop, the next batch is starting on 26th March, and the time is going to be 8 p.m. IST to 11 p.m. IST, and sorry, 8 p.m. IST to 10 p.m. IST. It's a weekday batch. Oh, okay, so if you want, you can enroll from CloudX Labs website. All right. Will you cover real-time analytics using Spark and Kafka? Yes. One of the project is around that in the course, in which we learn how to do Spark streaming using Kafka. All right. A question from Daraj is that this demo class is going on from USA or India. This one is being streamed from Bangalore. I'm located in Bangalore, India today, and all right. So in this session, there are people from across the world. So great, great. A brief about us at CloudX Lab. The agenda at CloudX Lab is we want to make learning fun and for life. Specifically, right now we are focusing on the core strengths that we have. We are focusing on the machine learning and the big data. And the way we are making learning fun is by the way of videos or live sessions, the quizzes, the hands-on, the projects, and the case studies. All of these are based on real-life use cases. All right, then there's something that we created after creating a lab. We are basically the pioneers of the cloud-based lab in the domain of big data and machine learning. So what we did was we created this online lab, which was really economical, and hence it is being used by most of the academic institutes as of today. So we also created something called automated hands-on assessment. The idea was that people should be able to learn by themselves by doing the hands-on. And so there is a problem statement. Then the learner would log in into CloudX Lab and solve that problem, and then it will automatically assess. So the assessment is instantaneous and automated. So this way, like for example, here we have a problem statement that says that log into CloudX Lab, and once you have logged in, click on I am done. So it automatically checks whether you have logged in or not. Okay, and then gives you the rewards accordingly. Here's another example whereby on the left-hand side you have a problem statement, and on the right-hand side you have a Jupyter notebook whereby you will write a Python code, Scala code, or Spark code. And from the left-hand side, it automatically evaluates whether you have done it correctly or not. For example, it is asking you to define a variable x and set its value to 10. And once you have done that, it'll say good job. So this is an automated hands-on assessment that we have done. And this ensures that you can learn at your own time, at your own pace, without the need of a third party. So if you have more questions for us, come over to the discussion forum. If it's a public question that you want the whole community to answer, we have probably in the domains of big data and Spark, we have probably the largest community. And so come over to the discussion forum and ask questions there. The email ID to reach us is reachus@cloudxlab. All right. So I'm the instructor for the class. I'm Sandeep Giri. I'm one of the founders of the CloudX Lab. And I graduated from IIT Roorkee, and then I've mostly worked on large scale computing. I started my career with DE Shaw, then worked with InMobi and Amazon. And mostly I worked on either large data or machine learning. Also, I have built all kinds of applications and tools. So at the heart, I'm a software engineer and I love explaining technologies. All right. And that's one of the reasons we started CloudX Lab, because there was need of need of learning material, need of practical learning in the domains like big data and machine learning. So that's one of the reasons why we started CloudX Lab. And the the main course, which is of the big data, the Hadoop and Spark, parallel to machine learning, is the objective of that course is to learn to process big data with Hadoop and Spark and everything that is related to that technology stack. So this course is probably the most exhaustive course on big data with Hadoop. It covers end-to-end entire stack with real-time problems and exercises. All right. So this is so before I jump on to the various definition, let me answer a couple of questions. A question from Satyam is, how is big data different from deep learning? We will learn it today. In case that is not answered by the end of it, please ask again towards the end. Which programming language would be used in the discussion of Hadoop? So today we are not going to use much of a programming language, but most of these sessions are basically programming language agnostic. The Scala part is the one where we need some kind of programming, and there we are going to go ahead with Scala with Spark towards when we learn about Scala and Spark towards session number 12 onwards. There we will basically be using we will be basically using the we'll be using Scala for Spark. Okay. Can I use big data with Microsoft Azure? Definitely. So the same Hadoop, specifically the one that comes from Hortonworks, runs very well on top of Microsoft Azure. They call it HD Insights. Okay, great. All right, let me just add one more person. Okay, great, wonderful. A question from Sachin is, Hadoop is not much relevant today. I suppose so. So it is important to learn for learning Spark. So yes. So basically the clusters Spark only provide in, okay, let me take a step back. Question is then, if Hadoop is not too much relevant today, then why we are learning it? Is it too much required for Spark? Answer is yes. Spark only provides computation, not the storage, and therefore it is important to learn end-to-end structure needed for big data. A question from Daraj, how to use the lab? You could go to the website and sign up for the lab. Okay. All right, great, great. Great. Uday, you have raised the hand. You have a question. Great. Let's start. Let's start. All right. So the first thing, the term that we are going to use again and again is structured data, unstructured data, and semi-structured. So it is important to learn that first. So structured data is the data having fields, and we also know the data type of each field. For example, in Excel sheet, or for example, in case of a database, we are very clear about the fields as well as their data type. Meaning, we are very clear about columns and their data types. Then the other form of data that comes to you is semi-structured data. Data that has fields, but we do not know the data type of each field. For example, the data in CSV files, the data in CSV files or XML, it is semi-structured data because mostly we know the fields, but we do not know their data types. Then the third kind of data that we will deal with is unstructured data, the data where we neither know the fields nor we know their data types. All right, great. So that is about data variety. And to transform unstructured data to structured data is called ETL. The full form of ETL is extract, transform, and load. Now, since the data is bigger, you need different kind of tools, and those are the tools that we'll discuss further again. All right, the other term that will keep coming again and again, the other term that will keep coming again and again is distributed systems. Distributed systems. And distributed system is nothing but groups of networked computers that interact with each other to achieve a common goal. Okay, so this is a very important topic. So distributed system says something, a group of networked computers which interact with each other in order to achieve a common goal. Okay, the most important keyword here is the common goal. What does it mean? Let's say you have a big work to be done, so distribute the work amongst multiple computers, and that is called distributed system. A cyber cafe is not really a distributed system because all the computers are not achieving a single goal. Meaning you're not all the computers are not achieving single goal, and hence you're not really dividing a particular problem or a particular goal into multiple smaller tasks being executed. Therefore, a cyber cafe is not a distributed system. Now, before I jump further, let me answer a few questions. A question from Guru is, I am beginner, where should I start from? Hadoop will be bit advanced for me. Not really. Hadoop will be okay with you. All right. Just that you need to know, its knowledge of SQL would come very handy. So you must know SQL, you must learn SQL. If you want to process data, the first step would be learning SQL. And then the second step would be to learn any programming language. All right. A question from Venkat is, Azure and AWS providing data lakes in cloud, is those different architectures compared to Hadoop? Generally, yes. They basically have their own internal tools parallel to Hadoop's file systems. Okay, they have their own proprietary ones specifically. Okay, Ari Ganesh's question is not sure whether I followed your comment on how to use the lab. You can actually just sign up for the lab, go to my lab, and once you've signed up, you can just go to my lab, log in into Cluster, and start using it. You don't need any installation. We have done the installation for you. Okay. A question from Sachin. Being a Java background, is it fine to stick with Scala only compared to Python? If you're, yeah, that's good enough actually to get most of the work done. Okay, because using Scala, you could do Java and other languages. A question from Abhishek is why big data is more important nowadays? I just need key reasons to know the importance. That's the next thing coming up. So hold on. Okay. So Kushma's question is, what is the difference between SQL and big data? SQL is basically a programming language to process data stored in the classic databases, say MySQL, Microsoft SQL, or Oracle, while big data is a term that defines that says that the huge data. Big data is nothing but huge data. All right. Can we use Python for coding? What are the other languages to learn? So Python should be very good starting point for you. Okay. Question. Okay. All right. These are great questions. And yes. Question from Guru, what would be better, Python or Ruby? I would suggest that you go with Python. Okay. If you are starting. All right. Also, the debate about languages is a never ending. Okay. So the answer is very simple. Just get started with any language and you will be able to use any other language as and when need arises. Okay. So there is no such thing called uh, in today's world, there is no such thing called something can be done in X language but not in Y. Today's time, everything can be done in almost every languages. Okay. And learning one language would open doors to learning another. So once you finish learning anything, any one language, you will have that quick learning ability to shift to any other language when need arises. Okay, so that's very important. So because the language wars are like political discussions, and we keep on going into the discussions. So if you are starting, if you have not learned any programming language yet, I would strongly recommend that you begin with Python. That will make your life easier. In case needed, you can move to any language afterwards. Okay. A question from Narjis is, do I need to know SQL with big data? Because most of the systems are evolving so that people could write SQL instead of writing any code. Therefore, knowing SQL will be really useful even in the case of big data. A question from Dara, is it required to know programming knowledge to work with big data? Not always. If you are from analytics background and you know a bit of SQL, you will be able to analyze and process humongous data using these platforms. Question from Abhishek is what is the criteria for big data internships for job pressure? So I would, if you could drop me an email at reaches@cloudxlab, we can answer that better, or you could drop it on the forum because this question is comprehensive, needs a far more comprehensive answer. Okay, in more details. I would love to answer this question. Okay. Sanjana's question is, would just having a background and experience in ETL, data stage, and no Java experience be good enough to start? Yes, that should be good enough to start. Um, just background experience. Oh, this is scrolling so fast. So let me just increase the window size so that I can. Okay. All right. So let me just show you this address on the screen so that if needed, you could just reach. Okay. Now, a question from Sanjana is, would just having a background and experience in ETL and data stays and no Java experience be good enough to? Yes, that should be good enough to start. Okay. Question from Daraj is that my focus is for learning data analysts. Focus is learning for data analysts. Under Hadoop, what should I learn? You basically will have to understand the big data basics, understand Hadoop architecture, and then you will have to learn Hive, and then you'll have to use Spark SQL. That should be good enough for you. Okay. A question from Guru is any Python-based framework that you would suggest? Is Django okay to proceed with big data? So basically, the Spark is available in Python also. So that's called PySpark, and that is good enough for any kind of computing. All right. So Django is more like a web application framework. Okay. A question from MX Guza is that if you don't mind, questions are great, but is it possible to take questions at the end of session? That's right. I would love to do that. But the problem is that if, let's say, you are having a question and I don't answer your question, the chances are that you will lose interest and you will not be able to focus on the current session. That's one of the reasons why I'll take quick breaks and then answer the question and then go with the concepts, then come back to the question. So I'll take breaks after every, say, 15 minutes for questions break. Okay, so let me see if we can do that. Maybe in every 15 to 20 minutes, we'll take the question breaks. Okay. A question from Manju is, do we need any license to use Zoom in US? The session is accessed from US. Yes, yes. So we have a licensed version of Zoom, but you can attend without using a license. Okay, it is free for attendees, but for the host, it needs license. So no worries for you. How is Hadoop different from Cassandra? We'll talk about it soon enough. Okay. Once we go through the architecture, then we can answer that question. Question from Sachin, is it easy to transition with, say, 10 years experience in .NET and now trying to move to big data? With my previous experience, we considered, or I would be considered as fresher. So your experience will definitely be considered because there are many things about computing that you would know even when you have worked with a different technology. Therefore, your previous experience is generally considered. Okay. A question is there any role of Excel in big data? Concept-wise, it is very useful, but as such, we do not process data using Excel. But let me explain once more. So for presenting the data in one of the projects, we will be using MS Excel. That MS Excel will actually bring data from the big data platform to present to you, as in MS Excel will be used as a presentation layer in case of big data, just like we use Tableau to do the presentation. All right, so MS Excel is definitely going to be useful. All right, very good set of questions. Okay, now there's a question that okay, let me just go ahead. Okay, let me explain once again. So the structured data is the data where we know the fields as well as the data type. For example, the data that we stored in most of the databases. Remember, if you create a table in database, you declare upfront the data formats, the data type of every column, right? So data in databases is structured because we know the fields and we know their data types. While semi-structured means we know the fields, but we do not know their data types. For example, let's say you have data that you have kept in CSV file. Now in CSV file, you don't have the column header, you don't have the column formats, right? When you want to convert the CSV file into RDBMS or into a relational database, you will have to infer the data type of each column, and that process is called ETL. Converting something from semi-structured or unstructured to structured is called ETL. Okay, then we talked about distributed systems. When we connect multiple computers to solve a single goal, then we call it distributed system. Okay, now a question to all of you: how many bytes are there in 1 petabyte? Use the chat window to answer quickly. So that's right. That's right. It's close to 10 to the power 15, or in other words, it's 2 to the power 50. All right. So yes. So petabyte means 1 followed by 15 zeros. Okay. Now, a quick question to all of you. The second question: how much data Facebook stores in 1 day? Anybody? As per their numbers, it's around 600 terabyte. As per their numbers, they have declared around 600 terabyte. So that's the kind of data they're storing every day. So now let's talk about the big data. So what do you think is big data? Please use the chat window to answer. All right, so good. So in very simple words, we'll keep the definition clear because every tool that we discuss as part of this course is a big data tool. So it's very important to stay clear with the definitions. So big data is simply data of very big size that you cannot process using usual tools. And for that, you need distributed architecture. What is distributed architecture? Many computers connected together to solve, connected together, and ability to solve the problem using many computers. So basically, distributed architecture is essentially ability to get work done using many computers. Okay, let's revisit the definition. Definition is simply the data with very big size. Now, how big? How big? that we cannot process with the usual tools. And what does it mean by unusual tools? Unusual tools means tools with distributed architecture. So in simple words, amount of data for which you need many computers to solve or to store. We call that data as big data. That is the definition we will stick with. That is the definition we will stick with. Now, it could be the data or it could be your needs. It could be the problem statement or it could be the size of data, which could push you for distributed architecture. Therefore, the most important part to remember is big data is all about distributed architecture. Every tool that we talk about as part of this course, starting with Hadoop file system, MapReduce, Spark, and everything that we talk about in this course is all about distributed computing. So this course is more about basically a course about distributed computing. So in distributed computing, you basically figure out how to get work done using many computers. All right. So the most important part here is distributed architecture. Okay. Distributed architecture means using many computers to solve your problems. All right. Now the data could be of any form. It could be structured or unstructured, doesn't matter. It could be semi-structured, unstructured, or structured. Okay, data could be of any form, but the most important part is when you can't solve using usual tool and you realize that for this kind of problem and this kind of data, we would need a distributed architecture, meaning we would need multiple computers parallelly to solve our problem. Now, this is a classic definition of big data. And so when we talk about data, or the characteristics of big data or data is it has three basic characteristics: volume, velocity, and variety. Volume means, okay, so when we say big in what sense? Is it big in terms of the volume, meaning if the problem is related to how are we going to store data, then we call the problem is volume related, the data at rest. Let's say you want to store, you are heading Gmail and you have to store humongous set of files and set of records every day. Okay, for that, the volume will become a problem soon. Now, for handling such amount of volume, you would require many computers having multiple hard disks or many computers having multiple storages to handle. So big data could be big by virtue of its volume. Or in other words, when you are faced with a problem where storing data is the main concern, then we call that because of the volume of the data, your problem is big data problem. Now, the second case is the velocity. Velocity is data in motion. Okay, there could be scenarios where your problem, the data that you're dealing is smaller, but because you need to handle such amount of data at very fast pace, you realize that one single computer cannot handle that. Therefore, you need multiple computers. So because of the data that is coming at speed to you, your problem has become a big data problem because of its velocity. For example, imagine how many requests are being received by Facebook. How many requests are being received by Facebook at every second? People across the globe are refreshing their news feed or checking their Facebook statuses, or notification updates are going to all the users across the globe. Now, If you imagine the number of requests it needs to handle, they are really huge. Even though the data in terms of exact data received or sent for notifications would be really, really small, but number of requests are high. And that's what we call the velocity characteristic of big data. Meaning by because of velocity, because of the need to handle velocity, your problem has become big data problem. Now, the third one is really interesting. The third characteristic is called variety. Variety means two things actually. Variety means the kind of data you have and the kind of data you want. Okay, so variety could mean two things. Variety could mean the complex structure of the data you have already and the complex kind of problem that you're trying to solve. So variety means the data in many forms. Okay, sometimes your problem statement is about dealing with small data and small velocity, but just because the problem that you're trying to solve is really complex, and hence it might demand you to run it on multiple computers. Therefore, variety is a problem. Okay, so variety also could push you to use multiple computers, and hence variety is also a characteristic of data that could make it big data. So imagine that you have to find the social graph, you have to find the path from one place to another. Let us say we want to go from one point to another in a map. We want to go from one point to another in the map, and there are many ways in which you can go from one point to another. To find the shortest possible path is a hard problem, is a complex problem. It requires a distributed computing or parallel computing to solve to find the shortest path. Okay, so finding path in the map is one of the examples of variety. So one the reason for going for multiple computers or distributed computing could be because of volume, because of velocity, or because of nature of your problem, the complex nature of your problem that we call variety. All right. So these are the characteristics of big data. Now, next question to all of you is, how much time does it take to read 1 TB from hard disk? Anybody? How much time does it take to read 1 TB from the hard disk? From the hard disk drive? Anybody? Just read. You are not going to store it somewhere. You're not processing it. Just reading byte by byte and ignoring it. 1 TB is 1024, which is around 1000 GB. So we are talking about an average hard disk. We're not talking about the one that is really costly and is yet to come to the production or the real environment. That's right. So actually for a classic standard hard disk, it takes around 6 hours. Okay. Movies. Try copying movies from one friend's hard disks, okay, to yours. Okay. So basically the time it takes is generally 6 hours for 1 TB. Okay. So we are talking about 1000 GB. Okay, if you look at 1 GB, it takes around 5 seconds to read from the disk, which is 5,000 seconds, and that comes to around 100 minutes. Okay, all right. So that is not 100 minutes. That is how much? So in general, when we did the calculation for average hard disk, it takes around in hours. Okay, there's no standard correct answer. The most importantly, the point that I was to the point that I want to bring out is it takes time to read data from the disk. It takes time to read data from the disk, and that's one of the reasons why we use many computers. Now, the next question to all of you is, if you have to count just the vowels in 1 petabyte data every day, will you use distributed system? Or do you need many systems? Every day, you want to just count vowels in 1 petabyte of data. Meaning, the problem statement is very simple. You're just reading the data, counting the vowels, and then ignoring everything, right? So my question is, can you do it every day using some form of a single computer? Would you require a distributed computing? Yes? That's right. For this kind of data, and this kind of problem, the distributed computing is required. Storing 1 petabyte data means thousand hard disks, right? 1,000 hard disks that you cannot handle on single computer anyway. Even if you did, processing this data in one day using one computer is impossible. So you will need hundreds of computers parallelly to deal with this kind of data. So, so 1 petabyte is big data. 1 petabyte is an example of big data because storing 1 petabyte data is a distributed computing problem. You need many computers to store 1 petabyte data and many computers to process 1 petabyte of data. All right. Now, next question is, why big data? Why are we talking about big data? The simple answer is that the data, this digital data, started increasing exponentially. And why did that happen? The answer is threefold. On one hand, the devices, the smartphone, the sensors, every device became faster, smaller, and cheaper. Faster, smaller, and cheaper, the three criterias for designing any hardware. Because of which, the phone that you have today with you is actually more powerful than the supercomputers of 2000s. In 2002, the supercomputer that we were using was actually inferior to the phone that you're using right now. The phone that you're using for playing Angry Bird is actually far more superior to the supercomputers of 15 years ago. So on one hand, the devices became cheaper, faster, and smaller. And on other hand, the connectivity became everywhere. There was Wi-Fi, there is 4G, there is an NFC and GPS. So the connectivity is there. So on one hand, you have devices with so many sensors, which are cheaper, faster, and smaller. And on the other hand, we have connectivity. And therefore, there's a scope of so many applications which are useful to people. And when we use devices connectivity by the way of applications, then a lot of data is generated. And that's why big data started mattering to us. That's why our data started becoming big data. All right. So it is inevitable. It is inevitable to handle it is inevitable to face big data for a company of okay size, decent size. Okay, when you have a lot of users. Now, so big data became omnipresent because of devices and connectivity and so many apps and libraries. Now, the computing component that we need to go over before we talk about anything. The four components that we all know. First one is CPU. We all know what is a CPU. CPU is a processor of your computer. Processor is basically the one which does everything. Processor reads the instructions from the disk and then executes those instructions. The more number of instructions it can execute per second, the more powerful it is considered. Okay, so CPU is one of the main components of a computer. Second one is RAM. In case of RAM, what is RAM? RAM is a really fast memory in which we read the data from slower memories and keep it here so that we can easily process it. So RAM is random access memory and is quite useful for all kinds of data structures. In case of RAM, what matters is the size and the speed. And RAM is the one that becomes the bottleneck first. When we deal with any kind of scaling, any kind of load balancing, RAM is the one which is the first bottleneck. It is not the CPU. The third one is the disk. What is a disk? Disk is a permanent storage. While on one hand, RAM is extremely fast, but RAM RAM is extremely fast, but RAM is not a permanent memory. Meaning, if you shut down the computer, everything that was there in the RAM get washed away. It's a temporary memory. The disk, HDD, hard disk, is a storage where data is there and it will remain there until explicitly deleted or the disk is damaged. The fourth component that goes ignored is the network. In your computer, in today's time, almost every application depends upon the network. And hence, if you have a slower network card on your computer, it is going to take a lot of time. Similarly, if your program is reading data from the network again and again, it's going to be far more slower. So you will have to keep some data local in order to avoid network. And that's one of the premises of something called data locality, okay, to keep the data local. And that's what we do in case of Hadoop, that we avoid the network calls because network is far more slower than the hard disk. Okay, so when we have these four components in the computer, one of these is going to be the bottleneck. When we deal with volume, is the hard disk that becomes the bottleneck. When we deal with velocity, either the RAM or CPU becomes the bottleneck. Okay, therefore, we would require many such computers in the network in order to solve our problems. When the data grows bigger, at least one of these components are going to be the bottleneck. Now, question to all of you is, which components impact the speed of computing? All of you? Which components impact the speed of computing? CPU, memory size, memory read speed, disk speed, or all of the above? The answer is all of the above, because in a software, if the disk is really slow, it will take long time to load data from the disk. If RAM is really small, then we won't be able to retain too much data in the memory, and continuously we'll have to keep pushing the data to the hard disk. Similarly, if the CPU is really slow, the chances are that your application is going to be slow. All right, so the answer is all of the above. The answer is all of the above. All right. Now, here we dealt about we talked about technology side. We talked about why the big data is a problem. The question is it useful? If so, why? Why can't we just sample the data and be happy and just keep the sample with us and do all the analysis with the sample data? Why big data is useful to us? The answer is very simple. More the data, better is the outcome. One of such cases is e-commerce recommendations. In the recommendation, or we also call it collaborative filtering, in the recommender or recommendation, such as Amazon, at Amazon, when you open a product, there you will see these recommendations. So this was actually the page that I owned at Amazon. So here, basically, you see the recommendations here, that you should wear this with these, that is manually created partially. And then the other one is people who bought this also bought that. So what you see here is the recommendations that are auto-generated by the system. Now, question is, if you have more data about the users, would you get better recommendations or worse recommendations? If you have bigger data, will you get better recommendations or worse recommendations? Okay. If you, let's say in your class, if you go um, onto the podium and ask all the students that how is the movie Matrix, and based on the voting that they do, you analyze which movie is better, right? So if your class has more student, will the result be better? Or will, if the students are lesser, will the result be better? Correct, correct. If the student in your class are more, the chances of average being right is very good, right? In the same way, while you are generating recommendations based on people's reviews and people's purchasing history, if the data is bigger, the chance of getting very good recommendations is high. Okay, you will get better recommendations if you have bigger data, right? So the point is more the data, better are the results. More the data, better are the results, specifically in case of recommendations. If you just kept the sample of the data, you will not get as good results as the big data could give you. Wonderful. Wonderful set of answers. Now, let me go over the big data customers and then I'll answer your questions. Similar is the case with Netflix. Netflix was the one who basically organized $1 million contest publicly on generating the recommendations. Also, the work that I did within Mobi was a recommender, building a recommender similar to this one, similar to the one that is on the left, where we were giving recommendations to the users. And this recommendation was based on around 200 terabyte of data. Okay. And that's why the recommendation was really, really successful. All right. Now, here is the very simple example of how do we, even if you are from non-technology background, you can simply figure out that it is not a rocket science as of today to do the recommendations, while at the time of Netflix, it was a big one. That's why Netflix basically gave a reward of $1 million to the team who won the contest of generating recommendations. All right. So the all right. Now let's take a look at, imagine that you prepare your data in the form of user ID, movie ID, and ratings. Let's say this is the data you have. User ID means the one column called user ID, second column called movie ID, third column called ratings, right? This is what you need to prepare. Then you feed it to a system like Spark MLlib, or earlier, the one that we did was based on something called Mahout. So we feed our data in this three-column format to Mahout or Spark MLlib, and Spark MLlib, the particular algorithm, the recommender would give us these three columns: user ID, movie ID, and ratings. Okay, so basically the recommendations are generated very, very easily. So based on similarity score of the users, the movies are recommended to each other. That is the very simple problem, simple way of solving it. Though recommendations are really hard when you want to attack the when you want to solve the accuracy. All right. The second one is the e-commerce. In e-commerce, we do the A/B testing. Okay. In A/B testing, what is A/B testing? In A/B testing, 50% of the visitors see a particular variation A, and the other 50% we show some other variation, say B. And then we observe which of the subset, which of the subset is giving us best conversions. Here, which variation do you prefer? A or B? Yes, correct. The A, the A is a better design. Why? Because that's the one which is giving us conversions. Okay, that's the one which is giving conversion, means user is converting to customer. Okay, so again, at Amazon, we really did A/B testing for each and everything. The button that you see, the buy now button, the color that we have there for buy now has come from A/B testing, and aggressive A/B testing, meaning observing which color gives the better outcome. And since we have bigger data, since I have millions of users, we would get better results. Okay, since is the bigger the data, the better would be the A/B testing. So again, in A/B testing, the bigger the data, the better would be the results. The third use case could be a government, because in case of government, everything is a big data. In case of government, whether it's fraud detection, whether it's cybersecurity welfare, whether it's justice, everything is a big data. All right. While telecommunication, we have eh, again in telecommunications, in telcos, the every data that you deal with is bigger data, and and the problems like finding problems like stopping the customer churn, meaning why are the customers leaving you, can be inferred using the data, using the customer's data, as in understanding how many hours they were online and how many hours they were offline, meaning they were not, the phone was not connected to the tower. What kind of signal did they have? What kind of how many times did they call you, as well as whether they made mostly the same state calls, different state calls, or did they make only the local calls? So we can stop the customer leaving us if we observe their behavior, we observe the data. Similarly, network performance optimization, calling data record analysis, and analyzing network to predict failure. All of these are a big use case of big data. Okay, before I move further, there's a question called what A/B testing actually is. A/B testing comes from medical drug testing. In 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 most of the drug testing, or in all the drug testing, what we do is for some of the patients we give the actual medicine, and for some of the patients we just give pacifier. Okay, and then we observe, as in we just give the water to other half, and first half we give the medicine. Okay, so we divide the patient into two parts and then observe whether the medicine is working or not, or whether medicine is making the patients worse. So that's basically A/B testing. A/B testing is all about observing objectively the effects of drug by breaking down the users into two subsets. Okay, by breaking down the the patients into two subsets. That's what was A/B testing. Same is applied in the e-commerce and other domains in order to observe the customer base. All right. So basically, taking the data-driven decision is essentially A/B testing. All right. So these were, and then healthcare and life sciences. In healthcare, health information exchange, gene sequencing, or healthcare improvement, or drug safety, all of these are basically big data problems. Okay. Here, the data is inevitably big data. So almost every problem after a point of time, after it has decent amount of users, would turn into big data problem. All right. So that was our big data customers. Now, a question is, we talked about big data solutions are, or distributed computing is the solution, but what platform should we use? There are many answers to it. What platform, what tools do we use? What are these big data tools? There are many solutions, tool or products or suites. There are many things, right? On one hand, we have on-premise. On other hand, you have the the on-cloud solution. Okay, hosted solution versus on-premise solution. Now, the on-premise solutions are basically supported by open source world, such as Hadoop and Spark. So when you want to set up your own personal cluster Hadoop and Spark cluster comes really handy. If you want to even install the cluster on the cloud, say AWS, then also the Hadoop and Spark kind of cluster is quite handy. You could also create your own cluster of Cassandra that could also help you handle the data in semi-structured or structured format. But Cassandra is not great for handling unstructured data like big text files. There, because Cassandra has been designed for mostly the structured data. Then we have MongoDB again. MongoDB, Cassandra, they all run on multiple computers. So MongoDB is very similar to Cassandra. It can give you a structured storage, but it can't give you, it tries to give you the file storage as well, but it is not that efficient with respect to files. The uh, the rest are say Google Compute Engine, AWS, or Azure. These systems are basically these systems are basically quite how should I say, so they are on the cloud solution. So if you put the data in on Google Compute Engine, you'll have to upload your internal data to an external cloud, for which not many people agree to. Okay, same is the case with AWS. So these are the various big data solutions. All right. A question from Abhishek is, what are the current big data projects and what kind of problems we need to solve? Okay. So basically, there are many internal projects which people are solving internally in their organizations. As I told you, these were just few of the examples in the telecom, in the domain, in the government side, in the bioinformatics, in the e-commerce, and so on. Okay. So there are many problems people are solving around the world using big data tools. All right. So though you can implement the big data solutions, you could implement the big data solutions either by using your own cluster like Hadoop and Spark, or by using Cassandra and MongoDB. But these solutions are not too generic. Here, this is the most generic. Okay, this is the most generic one. And here, the total cost of ownership is really low. Therefore, it would make sense to have your own cluster of Hadoop and Spark if you are, if you really want to process a lot of data. All right. So let me now take the questions. A question from Sanjana is, please feel free to ask questions. I would love to answer your questions. Okay. A question from Sanjana is, what is the best platform to solve problems? Okay. Out of all the frameworks, the most complete one is probably the Hadoop and Spark, because using Hadoop, you can store data in unstructured format as well as structured. Okay. And using Spark on top of Hadoop, you can do all kinds of complex processing. Whether you want to process using SQL, whether you want to process using normal programming language, or you want to process using, say, you want to process a graph, a complex graph of objects, just like Twitter follower and following kind of graph. So, or you want to process data to do the predictions using machine learning. So all of those things, though all of the kind of computation is possible using Spark. Let's say you want to process data that is coming really fast. For that also, Spark has a library. All right. So probably, in my opinion, if you have humongous data internally and you can manage your own cluster, then Hadoop combined with Spark makes sense. If you do not want to manage your own cluster, then you may want to host your solutions on AWS. But if you further want complete hands-free approach, then where you don't have to install or provision anything, then you can go for, say, Google Compute Engine or AWS, Amazon Web Services, and so on. Okay. Question from Muneshwar is, what is the major cloud in BFSI domain? In BS, the actually Hadoop and Spark combination is actually quite popular in BFSI domain as well. Okay. So this can be installed on your premise as well as on the cloud. Okay. So that's why people generally use that. Okay. A question from Channa is, what is Spark a cluster? No. Spark as well as Hadoop is nothing but software that runs on multiple computers. Okay. A question from Sheshu, how can we broadly classify big data solutions? Storage tools, processing tools, etc. Yes, that's one way to look at it. I'll go into more details. Okay. A question from Satyam. Question is, how is Spark and Hadoop different from Elasticsearch? Okay. So that's again a kind of big answer. So I'll just be brief. Spark and Hadoop is distributed technology solution. When you want to get something done parallelly using hundreds of computers, then you may want to use Hadoop and Spark together. All right. A question from MotoG. Okay, I'm really sorry, but you could have put the name. Do you plan to cover sample code example using big data platform, say Spark FW? So today I'm going to give you a quick demo, hands-on demo, okay? And if you want to take a look at the code example, you can go to our GitHub repository. We have put a lot of coding examples there, okay? GitHub repository is here, probably let me just see if I could. Okay, so let me just show you our, if you want to take a look at the coding repository, it is here. All right. Okay. All right, great. Now going back to what we were doing. All right, so this is the repository which has all kinds of possible code. A question from Sindhu is, how is Spark different from big data components like Hive, MapReduce, and Pig? So Spark is basically faster than that. We'll talk about it today. Okay. All right. Next question is, what makes Cassandra handle more scalable data? Okay. Facebook recently came up with Cassandra. If Hadoop with Spark is good, then why Cassandra? So actually the innovations of Hadoop and Spark and Cassandra happened parallelly. Cassandra is great for very fast updates, while Hadoop and Spark are generally known for handling data which is relatively static. Okay, but given H-based kind of solutions is actually very comparable to Cassandra. H-base is a NoSQL database, meaning a database which is very, very simple and fast and distributed. So Cassandra also scales well. Cassandra also can run on multiple computers and so on. Okay. So the evolution actually happened parallelly, the development happened parallelly, therefore there is no question of A or B. Okay. A question from Kushma is, what is distributed cache and its benefits? When we install something in Hadoop, it is distributed, the whole installation is done on all the machines, and that storage is called storage where the application is being installed on all the nodes is called distributed cache. We'll talk about that during the course. Okay. A question from Chandana, what is yarn? We are going to talk about it soon. Okay. A question from Sachin, is it important to pay to use your cloud? Okay. It is important to pay to use your cloud. Not really, not really. I'll tell you why. So why we set up the CloudX Lab cloud, first of all, basically we were facing a lot of problems in people learning, and we realized that it'll be easy for the user if they have a ready-made cluster. Like in organizations, what would happen is most of the engineers, they will get the pre-installed cluster. They would not be creating their own clusters all the time. Therefore, it made a lot of sense to create a cluster for the users, for the learners, and share it across. And that's what made CloudX Lab. Okay. So, so basically, since we pay to AWS for the bandwidth and for the servers, that's the reason why we charge our end customer. All right. That's why we are asking for a small subscription fees. A question from Avinash. What are the prerequisites to learn big data and Hadoop? Being a fresher, can learning land a job without an experience? A good question. So let me just repeat that if you are a fresher, okay, learning big data and Hadoop is definitely going to give you more visibility to your CV. Definitely. Having said that, I would still say that you must learn SQL and a programming language if you are a fresher. If you're good with that, then you must go for big data and Hadoop or machine learning. Okay? It would definitely give more visibility to your CV. A question from Chandana, do Cassandra and MongoDB both have same features? Are there major differences? Okay, so Cassandra represents the data table in a columnar format. We can go into more details at later point of time. Okay, while MongoDB has a JSON kind of storage format. Okay, so Cassandra and MongoDB, the data structure is different. Okay, and Cassandra has a very tunable consistency. Therefore, Cassandra is generally considered a better choice in most of the cases, except for the cases where you're trying to store only the documents. So Cassandra generally wins in between Cassandra versus MongoDB, but MongoDB does well when we have to store huge objects. Okay, very good set of questions. How is the cluster structured? How does it scale? Okay, that's exactly that we learn as part of the course. So we have multiple machines in which we have installed various masters and slaves. We talk to the masters, they create the slaves, and then they interact with the slaves and get the work done on the slaves. That is basically a very, very simple thumb rule. Okay, so basically Hadoop and Spark both are nothing but bunch of softwares. Okay, and when we are installing Hadoop and Spark, we generally install them on multiple machines. Okay, and as and when the load keeps on increasing, we keeps on adding more and more machines to the Hadoop or Spark cluster, and it automatically scales. Very good set of questions. Okay, a question from Daraz is that which one you recommend for small business solution? For small business solution, I would generally recommend AWS or Google Compute Engine instead of setting up your own cluster. But setting up your own cluster is not a very big problem. Okay, what's the difference between Hadoop and machine learning? Hadoop is an ecosystem of components to do distributed computing. Okay, to do computing using many computers, while machine learning is the ability to predict, is ability to come up with a logic by itself. Okay, so machine learning is all about getting work done automatically using the machine. Okay, instead of, while on the other hand, Hadoop is a suite of components that get your work done on a cluster. So on one hand, the Hadoop is basically a software, while machine learning is a technique, or machine learning is bunch of algorithms. Okay, good question. Now moving ahead, a question from Avinash. Avinash, is Python necessary to be known before learning big data with Hadoop? Not really, not really. Okay, core Java can still do it all. Okay, question is, what does R language have to do with data analytics? R is a very, very simple language in which where you can do interactive analysis, but the same thing could be achieved with Python as of today. Okay. A question from Manju is, when we have HDFS, why we need Cassandra or MongoDB? You don't need. Okay. But you need something called HBase that we'll talk about soon. Okay, I think you all are ready for the next point. Now, question from Abhishek is, what are the most big data problems need to be solved in 21st century? There are many big data problems that need to be solved. Okay, and there are many fold dimensions to the problems. You will see that soon. Okay, specifically related to machine learning kind of problems. They are also basically big data problems that need to be solved. Okay. There are many problems actually. So that basically would take me a while to answer. Okay. A question from sorry, sorry, it's Galaxy Tab E. Okay, it would be great that if you change the name. I love to, um, I love to, uh, I love to address people by the name, and okay, that makes me really comfortable. And okay, so I have 7 years of experience in mainframes. Okay, look, that's a question from one of the audience. Okay, so is Java necessary to learn Hadoop? Not really, not really. Okay, how much Java basics needed to learn Hadoop? Okay, let me just answer this question. This is an important question and would keep coming. Question is, do we require Java to learn Hadoop? If you are programming for Hadoop, then you require either Java or any other language, but that's no longer required because programming, we have moved to Spark. Okay, in this particular course, we are using Spark with Scala, but Spark can run with many languages. Therefore, if you do not have the knowledge of Scala, then also you can handle the Spark. Okay, even though we are going to teach you Scala as part of this course. Okay. Question from Satyam, is there a difference between Hadoop cluster and Spark cluster? Uh, yes, we will talk about it very soon. Okay. A question that, from Daraz is, what is the difference between data engineer versus data scientist? Data engineer basically takes care of transformations of the data, utilizes algorithms, while data scientist comes up and fine-tunes and debugs the algorithm part of the machine learning. So data engineer does not necessarily know very details about machine learning, while data scientists need to know the machine learning as well. Okay. A question from Kusuma, the difference between big data and RDBMS. In case of big data, let's take a case of say Cassandra, MongoDB, or HBase. They are the equivalent of any relational database. Okay, so there, let's just compare the HBase or MongoDB. On one hand, we have HBase, MongoDB, Cassandra. On the other hand, we have RDBMS. In RDBMS, you always have one machine operating and giving the results. correct? In RDBMS, the work is not distributed. You want to insert record, update record, read a record. The request always goes to one machine, though there are backups, but they are not being used. So RDBMS is not distributed, while the big data or NoSQL component, we also call Cassandra, MongoDB, and such kind of tools like HBase as NoSQL because they are not like SQL. We call them NoSQL. So basically, the NoSQL tools or big data counterparts of RDBMS, they are distributed. They all run on multiple computers. Cassandra runs on multiple computers. MongoDB can run parallelly on multiple computers, and so does Hadoop's component called HBase. All right. All right. Avinash, was I able to answer your question? A question from Avinash is, can you please suggest any institute for learning big data in Delhi? A very candid answer I love to tell you is, do not look for a local institute, okay? Because you may not get a good experience. Though on internet, you will find all of the content related to big data and machine learning or any components for that matter. The reason why people attend, say, my classes or any classes is so that you can get your questions answered. The most important thing to get started in any domain is to be able to get answers to your questions. Okay, so there are many books, there are many videos, many YouTube channels, many websites providing you content. So there are many, the content is available everywhere. The reason you would like to attend a course or institute or a live course is because you want your questions to be answered, right? So to get your questions answered, I would strongly recommend that pick up any online course. You can also check out the course which we have, but I will strongly recommend that whosoever course you take the online course, because that's where the chance of getting somebody who is a practitioner who has done some work, the chance of getting that kind of instructor is very high. Okay. All right. There are quite a few questions, and let me let me answer this after the break. Okay. And all right. So there are 4 or 5 questions. Let me finish, take a break, and then we'll come back. All right. Okay. So break for 10 minutes, and we'll be back by 9:43 p.m. IST. Because I'm located in IST. All right. So please post the time in your own time zone. That'll be useful to all the users. All right. Hi everyone, I am back. So should we start now? Great, great. All right, so let's start. All right, all right. Feel free to ask questions using the chat. Sorry, feel free to ask questions using a Q&A and answer the questions using the chat. Okay, so all right. So before the break, we were talking about the various kinds of solutions for big data. All right, and these are not strictly solutions. These are all various possibilities that you would go with when you want to deal with big data based on your requirements. Let's say your organization does not want to go with a hosted solution. You want an on-premise or private cloud. Then you would like to, or you may want to go with the public cloud. Okay. You may also, instead of taking care of the headache of installation and management, you may want to go with the services like Google Compute Engine or the S3 and the other solutions provided by AWS instead of managing your own cluster. Or you may want to go with your own cluster. So it is up to you. It is based on your requirements. Okay. So a question was from Sanmugaraj, that the one that we couldn't answer before the break. I'll answer these questions, and then what we do, then after these questions, we are going to talk about each component, and parallelly, we will do the hands-on. Okay, that hands-on will help you get started with these components. And in case you are um, in case you are more of a doer, then you would love to do hands-on on the lab right away. Okay, so and then you will come back and learn again. So everybody has their own way of learning. Some people want to learn theory first, then want to go for practice. Some people want to do the practice first and then come back and learn theory. All right. So we are going to do both today after this. All right. All of you will get the complete recording. Don't worry. In case you want to take a screenshot, you can take a screenshot. Feel free to blog about it if you maintain your own personal blog. And feel free to let us know if you have more questions. So let me go further. Question is, I am working with BI and DW. Okay, BI means business intelligence, and DW means data warehouse. With 12 years of experience, to upgrade skills, I'm planning AWS, Azure, Big Data, Hadoop. Kindly suggest. So I would say that out of these, the knowledge of AWS would come handy. That would, because most of the Azure is kind of architected parallelly to AWS. So if you are comfortable with AWS, you will be able to, move on to with Azure as well. Second, the reason, if you have to learn one of the two things, then I would suggest AWS. Now, with respect to big data and Hadoop, what I'll suggest is that learn both parts, AWS as well as the Hadoop and Spark, because they are complementary skill sets. All right. So the Hadoop and Spark is, we have combined it together into a single specialization. You may want to start from there. All right. And the way most of our learners do is they take up the self-paced, and if at any point of time they feel like joining our live instructor-led course, they can just join the course at any time. Okay, so that's the general algorithm, general strategy people use while learning with us. So they take up self-paced. With that, you get 3 months of lab. You have the content for lifelong. You have exercises. You have hands-on assessments and projects. And once that is done, then you can go ahead with go if you still want live instructor training, you are not comfortable self-paced, then you go with the you get it converted into live training. All right. So I hope I was able to answer your question. All right. Question from Santosh is, how is big data and data analytics are related? So big data is about handling the various form of data and distributing the computation. The computation could be related to the analytics. Analytics involves Analytics involves churning the data, filtering the data, and so on. The similar techniques could be used using distributed computing, using Spark and Hadoop. So you can do data analytics using Hadoop as well. And the with respect to AI is basically a term. It's a term which is defined by the objective. AI means we want to create something which behaves like human. Okay, so AI essentially is kind of not a technology. It kind of is a term, kind of an objective that we would like to do. We would like to build some tool which could behave like humans, and that is AI. All right. I hope I was able to answer your questions. All right. A question from Jamilo. The question is, what is the difference between HBase and Cassandra? So Cassandra, the HBase is a part of Hadoop, while Cassandra is an independent tool. For HBase, you require Hadoop. For Cassandra, you don't require Hadoop. And so if you have a Hadoop cluster already, you will get HBase. You would not require Cassandra as such. But if you want only the massive, you want to store only massive structured data, then you may want to use Cassandra on if you don't want to store the files and other forms. Okay, so that's basically the difference. A question from Amit: How come e-commerce recommendation completely related to big data or Hadoop? As you told, you have worked on it. As per my knowledge, this recommendation should come with the concept of machine learning. Very good question, Amit. Question is that I talked about recommendations, correct? I talked about the recommendation system that I built at InMobi. So there, the problem was 5% machine learning and 95% data engineering. Okay, selection of the algorithm and various statistical techniques were based on machine learning, while acquiring the data, storing the data, filtering the data, processing the data, and making it presentable to the algorithm is entirely data engineering work. Okay, so 95% of the data related problems are data engineering work, while 5% or lesser than that is data scientists work or machine learning work. Okay, good question. All right, so all right, let me just clear it up. So all right, a question from Divya is big data help in web development? It does. When you have massive amount of data in your web application, inevitably you will have to move to big data storage. For example, in case of Amazon e-commerce website, the backend was mostly RDBMS at that point of time when we were building the e-commerce portal. But later on, we moved on to our own NoSQL solution, only the transactional data in which we keep the transactions, in which we need a strong consistency. In those cases, we were using the Oracle at Amazon, while for others, we were using our own NoSQL database. A question is, what is the difference between Hadoop and Tableau? Hadoop is basically for processing data, storing data, and so on, while Tableau is for presenting data. Okay, so Tableau can connect to Hadoop and present the data. Very great questions. Even if you did not ask the question, please pay attention to the question. These are really, really important questions that could help you in your interviews, that could help you in clearing up your understanding of various components. All right. I hope I have not put you guys to sleep. All right. So okay, a question from Perumal is, what is the difference between Spark and ELK? Spark is a complete stack for processing data, which is relatively um, big, while the ELK is kind of mostly the log processing stack. So the two basically caters to different set of use case. All right. A question is, I worked for last 10 years in development. Today, I work as administration of cluster of Hadoop and want to move on architectures. Any idea? So yeah, so I think doing a Hadoop and Spark engineering course would definitely help. So the course that we have, probably you can start with that. And since you have already good experience in development and the cluster, this whole learning will be really, really quick and effective for you. Okay. Question from Abhishek is, should we try to make project first or learn concept, then try to for the project in big data? And focus and start. So it is up to you. So the way we have figured out is a bit of theory, bit of hands-on, bit of theory, bit of hands-on is what makes you learn things. Okay. Neither, if we start doing the hands-on, that's actually could be slightly better than doing no hands-on. Okay, so theory generally doesn't stick. So whatever we have talked about till now is mostly theory, and if we did not ask questions, the chances are that whatever we talked about till now, you will forget. Okay. A question from Sheshu is, so many brands and terms in big data arena, any index for this in line with what you explained? I have not created an index, but I would love to because this is the third request I'm getting this week. So would love to do that. Okay. Thank you, Sheshu. So do you mean we have more opportunities in data engineer than data science? Actually, the opportunities definitely would be there in data engineering, but data scientists are also decent engineers. So whatever data engineer can do, if data scientists can do, then basically both have kind of good opportunities. All right. So a question from Guru, shall we keep the big data separate from web application? Mm, Generally, you don't have that luxury. If your application is being accessed by many users, a humongous set of users, then your data, the data that is coming from users, would have to be moved to any NoSQL storage and so on. So you can't really keep big data separate from web application, but the tendency is there always. Okay. All right. A question is any idea to become big data architect without a lot of years of experience? Short path. So I think the easier path is that you basically attend the course like Hadoop and Spark specialization we have. That'll give you the entire understanding of the architecture, and then just start doing hands-on so that you will be able to answer a lot of big data questions. And when you work on more projects related to the data or big data, you will be more comfortable and you will be able to come up with the architectures. Okay. Question is NoSQL database the same as big data? So big data is basically, yeah. So NoSQL is for storing semi-structured or structured big data. Okay. A question is 5% work is done by machine learning and 95% by big data developers. Then why data scientists are paid higher than big data engineers? Because they can do both the works. Okay, that's one of the reasons. All right, that's a good question. And how to report tool under big data? So you do the processing using Hadoop or Spark, and then report using Tableau, BERT, or any other BI tools. Your standard one using Excel. You can do all of that by querying, say, Hive or Spark SQL. Okay. Question is, can we migrate from current relational database to Cassandra or Hadoop or Mongo? Are there any tools? Yes, there are tools. Okay, great. So um, I hope I have answered your question so far. All right, let me just clear the questions. A question from Santosh says, a difference between Tableau and Kibana. I think that I'll have to take a look at both of them. I have, limited experience with Tableau and Kibana. So a better one would be that I take a look at both of them in detail. Question from Satyam is, will there be more such sessions? Yes. Actually, we are planning the more hands-on series very soon. Okay. Probably in a month's time, there'll be more and more of online web series for hands-on. Okay. So pay attention to the theory so that we can go ahead with the hands-on. How to report tool under Hadoop. So the reporting tool basically will connect to one of the services of Hadoop, and that's how it'll work. Let me just talk about it soon. A question is how to use big data with images, videos, and text. You have the tools for all of these under a Hadoop or Spark to process any kind of data. Okay. All right. So now let's. I'll come back to your questions probably after this. Okay, because your questions are really interesting, and I would love to answer these probably towards the end. So I would like to spend next, say, 30 minutes doing hands-on. And these questions that you have asked are very important, just that I want to answer them towards the end. Okay? So before leaving the session, I would answer all the questions. Okay? Good, good. So all right. Let me just promote one of my teammates. All right. So let me just give me a second. So, all right. So yes. Now, good. So I'll just give a brief about Hadoop. So what we're talking about so far is that since processing humongous data needed many computers, so the new kind of softwares were required in order to distribute the work. And that's exactly the whole evolution, the whole um, array of softwares came into play. One of them is Hadoop. Hadoop is basically was created by Doc Cutting from Yahoo. They were trying Doc Cutting and Mike Caffarella. They were trying to build they were trying to build a search engine like Google, so that they could provide very good results to the people. And then, while they were building a search engine like Google, they realized that storing data from across the globe, because when you build a search engine, you have to crawl the data. You have to get the data from every website and prepare the index. The way, the way on the back of on back of the book, you have the index whereby there is a keyword and the page number. In the same way, when you build a search engine, you'll have to download all the website, store it somewhere, extract the details about various keywords and various things. So you will have to, okay, you will have to build basically a humongous storage to download and store all these websites. This is where they were stuck. Doc Cutting and Mike Caffarella, while building the search engine, they realized that they can't move on until they figure out how to store petabytes of data. And that's when Google published that's when Google published these three papers. The three papers, first one was Google File System, second one was Google MapReduce, and third one was Google Bigtable. So the way Google built a file system, what's a file system? A place where we create folders, we upload files, that is a file system. So Google built this file system which could store massive amount of data using many computers without the developer having to worry about many computers. So Google File System was a breakthrough in the sense that it could store humongous amount of data. Then there was Google MapReduce. Google MapReduce was for doing the computation using many computers. And that was a software as well as a framework. And then Google Bigtable. So Google published these three papers, and Mike Caffarella and Doc Cutting, they basically took these three papers and created Hadoop. They basically implemented the same papers, okay? And that became Hadoop, and it was named after the toy elephant with which Doc Cutting's son was playing, okay? The most important part that made Hadoop successful was the licensing. Licensing of Hadoop is really, really liberal. Licensing of Hadoop is liberal, meaning it is a license called Apache. Again, Apache was a software. Apache was a software made for the web server, and that became so popular and powerful. It became a community in itself. It became a software movement in itself, and hence Apache became a licensing model. Okay, so Hadoop comes under Apache license, which is the most liberal license, meaning you can use Hadoop for academic purposes, you can use Hadoop for commercial purposes, you can use Hadoop for learning purposes without having to worry about license costs. Okay, so Hadoop is absolutely free. It is open source and free. Okay, it is powerful, popular, and supported. Okay, it is powerful in the sense that it can do a lot. It is popular means it is being used by many people, and it is well supported. It's a framework to handle big data. And what does it mean by handle big data? It all the components. As later on, while Hadoop started with these three components, a file system, a computation engine, and NoSQL engine, Hadoop started there, but it became an umbrella of components. And all the components that lie under the umbrella of Hadoop, all of them can run on multiple machines, meaning they are distributed. They are scalable, meaning today you have 10 computers, tomorrow you have 20 computers, and still you don't have to worry about it. And that's called scaling. That's scalable. Third is reliable. If some of the computers go down in the network, still the Hadoop and its components will work really well. Hadoop is written in Java in the sense that most of the tools under the umbrella of Hadoop, almost all of the tools are written in Java because the design was such that it could run on all kind of platforms. Okay, so this is the definition of Hadoop. Okay, and right, so it is free and you can download it. So there are two major companies who provide the support around Hadoop because Hadoop is well supported. One is called Hortonworks and other is called Cloudera. So Cloudera basically started the first version. Docketing was working with Cloudera in the beginning, and later on, the Hadoop 2, the first architecture was done by the founder of Hortonworks. Okay, the architecture of Hadoop 2 was done by the um, the founder of Hortonworks, and that's where Hortonworks also became a company which supports and packages Hadoop in their own packages. So Cloudera and Hortonworks basically repackage Hadoop along with their own tools and provisioning systems, while Hadoop remains plain vanilla open source software. The Cloudera and Hortonworks, they package, support, and also add bells and whistles, as in more components and tooling around these. So that's what is Cloudera and Hortonworks about. Now, at CloudX Lab, what we have done is we have installed all of the components from Hortonworks and then remaining components from Cloudera. So let me just draw and give you a picture of what we're talking about. Okay, so you can see that. So it's like this. Okay, so this is Hadoop. Okay, this is Apache Hadoop. Okay, Apache Hadoop, and this one is say Cloudera, and this one is Hortonworks. Okay, so this one that you see, this circle, is how do you fill the things? Okay, never mind. So I'm going to move on now. So this part is Hortonworks, which has Hadoop plus. Let's say there are a few more tools like they have Ambari, and they have few more extra tools this side. Okay, while on this side you have say Hue and so on. So there are few tools on both the sides. There is Cloudera Manager, okay, which is specific only to Cloudera, while both of them have this. Okay. Now the same thing, this is also called HD Insights as published with Azure. Okay, so basically what we have done is we have installed both the things. We took the entire Hortonworks package, installed it on the CloudX Lab, then we added the components from Cloudera. Okay, okay. Now, how do you get access to Hadoop? You can actually download maybe HDP, they call Hadoop Hortonworks data platforms. Okay, Hortonworks data platform. Either you could download from there or you can download from Cloudera virtual machine, but then it would take a long time to get you started. Okay, so if you don't want to go with CloudX Lab, you could just install Hortonworks data platform from here, the virtual machine. There is something called virtual machine, and if you want to set up in your cluster, you could use the Ambari. Or if you just want to learn for now and do the hands-on, you can go for CloudX Lab. Okay, you could go for CloudX Lab. Okay, all right. These are the basic companies, Abhishek. I hope that answers your question. All right. So basically here you can to sign up for the CloudX Lab. You can go for enroll now there. Okay. So here, should I say, let's say you go to the lab, you could just sign up from there. All right. You could sign up for 1 month, 3 months, or 6 months. And here there are many tutorials. Most of them are free. For example, Linux Basics is free, Introduction to Python is free, Java Essentials is free, and Big Data Introduction, the one that we are doing right now, is free. HDFS is free, MapReduce Basics is free. So you can start for free. Okay. And yeah. Now let me just log in using Google, my account. All right. Okay, so I've logged in, and when I go to my lab, I see these credentials. I have my lab credentials, and I can log into the cluster easily. Okay, so let me give you a brief introduction of things. So as I told you about two things here. So we have Hue, which is only on Cloudera side, and we have Ambari, which is only on Hortonworks side. Ambari is provided by Hortonworks so that you can easily install Hadoop and other components. So that's what we are using. So let's take a look at Ambari. Okay. So we have installed Ambari also for you. So Ambari basically is what do you say? Ambari is tool that could help you install Hadoop. So this is where we generally start. So let me just log into the admin account. That will look better. Okay. Satyam, can I answer your question later? Right? I can see that. All right. So please hold on to the question. I've seen the question. All right. So now, so what we have is the basically Ambari. Ambari helps us installing to more hosts. If you are going with Cloudera, you would generally be using Cloudera Manager instead of Ambari. Okay, so So that's basically getting started. But in case of Cloud X Lab, you don't need to worry about any installation. We have done it for you. Okay, so you can see that there's HDFS, Yarn, and all of these components. So let me give you a brief overview of what do these components do, and then come back here. All right. So Ambari is a provisioning tool or administration tool which could help you install various services as well as manage various services. If I have to stop HDFS, I can click on service and stop. I can stop. If I want to stop any of the components of Hadoop, I can stop that, right? So now going back to the discussion where we were. Okay. All right. So now let's talk about the basic system, right? A very relevant question right now. Question is, can we scale up, scale down nodes from the cluster using Ambari? Yes. We could just go here and stop the host. That is essentially the that is essentially the we can put it in the maintenance mode. Okay, stop all the components. That's how we can scale down and scale up using Ambari. Okay, good questions. Moving ahead. Now, Hadoop distributed file system is the first component of Hadoop. As we talked about data processing, data this, data that, the first thing that comes into play is where would I store data? Where would I store data? Right? And data in the most raw form is files and folders, correct? So the first thing that was needed was a place where we could store data in the form of files and folders, right? So why it was needed? Because to store data on hundreds of disks is impossible to manage. If we have like 100 disks and we basically mount them on multiple computers and try to manage them, it becomes a nightmare. And trust me, we have done that. At DSHA, we had done that we had like thousands of disks in thousands of computers to manage, to build a huge storage. And it was a huge nightmare to manage it. We had to essentially build a similar file system the way you see today in the form of HDFS. The idea is to utilize thousands of computers and hiding the complexity from the users. Okay, so the data is stored on many computers, and many computers are involved in reading and writing data. So HDFS is the one that does the magic for us. Okay, now let me show you how does this look. Let's log into Hue. Hue is the interface from Cloudera, which lets you interact with all kinds of tools from the browser. Okay, so you have, let's say, this file browser. What it does is it provides you an interface for HDFS. This is DHDFS. This is Hadoop Distributed File System. What it does is it gives me access to all kinds of files and folders. This is my files and folders. This is my home directory. If you want to go to another directory, you can click on / and go there and so on, right? So this is HDFS. You can see that. So this is how HDFS is. Now, the important part is some of these files internally could be on one machine, could be on another. And you can see here that, okay, you can see here that there are so many machines here, okay, which are running. Don't go with this. It just, we have stopped some of the services and some of the services are not reporting here, but the system is working perfectly and fine, except for this particular machine, which we turn it on whenever need arises. Now coming back to it, so what you see here is, what we see here is that we have so many so many hosts, and are these hosts are having all these components. Okay, and all of these machines must have the same OS version, and installation is generally done by Ambari itself. For our case, if you are going with Cloudera, you generally go with Cloudera Manager, which is similar to Ambari. Now coming back to it, so there are so many machines, and this file system, you see these files? These files are stored some on one machine, some on another, some on another. So that way, it's heavily distributed and heavily load balanced. If some of the machines go down, still the cluster will keep running and everything will be okay. All right. So this is the Hadoop distributed file system, right? Did I make sense to you? So this is Hadoop distributed file system. So the licenses are completely free. If you want to build any solution, you can definitely build without paying anybody. We charge a very tiny amount for the lab because we pay to AWS so that our students could do the hands-on. Okay. And if a machine goes down, there are multiple copies of the data and that gets recovered. We can go into more details in the second session onwards. All right. Next one is the resource manager. What is resource manager? To get work done on top of Hadoop file system, because Hadoop file system is on different machines, is under the hood being run by how many systems? Around 7 systems in our case. Okay, Hadoop file system is internally, the data is on 7 file system, 7 computers. Okay, and those 7 computers basically are contributing to the file system. Now, we would like to process the data on these 7 computers instead of on one computer, or instead of bringing data to one computer and process it there. So Yarn makes it possible to run the logic on many computers and to run the logic near to the data. Near to the data. That's the most important part. Okay, so you have a cluster, you have a cluster of computers. Let's say this is your file system, and we have, let's say, this is one storage, this is another storage, this is another storage, this is another storage, right? These are basically the computers, right? So Yarn makes it possible to do the execution nearer to the data. It makes it possible to do the execution nearer to the data. So we could run logic here, we could run logic here on this computer, we could run logic here, could run logic here. So basically the data will be read from here. Okay, this is our process, this is our hard disk, this is our process, this is our hard disk, and this is our HDFS. So when you are running logic in Yarn, this is our Yarn. Okay, I'm really bad at trying, so let me try to fix it. So this is our Yarn. Okay, Yarn, Y-A-R-N, this is Yarn, this is HDFS. Okay, and when we distribute the work, Yarn makes it possible to process data in parts. Okay, this is computer 1, this is computer 1, this is computer 2, this is computer 3, this is computer 4. Okay, so you run the logic here. I'm stepping ahead really fast. Okay, so we will go into more details about how to actually achieve this. Okay, how to actually achieve this. Achieving this is actually, even after so many frameworks, it requires a bit of thinking. It requires a bit of learning. And there is a bit of learning curve on how to divide the work on so many computers. So here is the storage, here is the work. Okay, so that is resource manager. So resource manager is like a distributed operating system. Resource manager is like a distributed operating system. Now, the next thing we have is a compute engine. Next thing we have is a compute engine that's called MapReduce. A MapReduce could be any logic, any Java program, or any program for that matter, because using Java you can call any program. Correct? So MapReduce essentially could be written in any kind of programming language. So MapReduce is one form of computation, done on top of Yarn. MapReduce is just one form of computation done on top of Yarn. Okay, then we have Spark. Spark is another form of computation. Spark is Spark is another form of computation. Is everybody able to hear me clearly? No? All right, great, great. So now the other form of computation is Spark. So we write our program for Spark, or we write our program for MapReduce, and MapReduce or Spark, they're basically competitors. They're frameworks for the computation, or you can say the tools that take the logic from you, execute using Yarn on many computers, right? So that is how it works. Now, the third thing is a very important thing called NoSQL data store. Before jumping ahead, let me just show you MapReduce and Spark. Okay, MapReduce and Spark, and then we'll talk about anything. I hope that's okay with you. I would want to, even if you don't get anything, just stay with me and trust me that it is going to be useful. Okay, it is going to be useful. So let me just show you few more things. Okay, why it is okay. So now we talked about few things. We talked about HDFS, right? Now let me show you one more thing in the lab. So I showed you what is Ambari. I showed you what is Hue. Then we have something called Web Console. Okay, what does Web Console do is Web Console lets you log in from the browser. Okay, you could also log in using SSH or PuTTY from your desktop. Now, logging in means you virtually reached on our server. This is one of the machines called e.cloudxlab. Right now, any command I do, it'll execute on this server. Okay, say for example, I'm doing pwd or ls. pwd means what is my present directory. ls means show me the list of files. These are my files. Okay, but these are not on HDFS. They are on this machine locally, not on HDFS. All right. Now, let's say I want to execute something on Hadoop, right? So all I have to do is let and we could say that Hadoop jar. Using Hadoop jar, we can execute our MapReduce program. Okay. How do I execute Hadoop jar? Hadoop. Okay, I'll have to look at one of the commands. Okay, so I could say, okay, All right. Actually, we could execute any of these programs easily using the same one. It's just that I'll have to take a look at the command exact one. Okay. All right. Can I just show you? All right. Let me just open one of my available. All right. Let me just show you this one probably. Actually, here, if you go to my lab, go to home page. Okay. If you go down, you will see MapReduce Basics. All right. Here we talk about what is MapReduce and how does it work. Along with that, we have say using the examples and the resources. All right. So here is one of the use case. All right. So let's say this is our file that we would like to do the processing of. Okay. I'll just give all of you this link. All right. So not this link. I'll just give you a proper link. I just want to demonstrate to you how does the MapReduce work. So what we are trying to do is to do the MapReduce. How does it work? Although it may not be needed for you, but it would be easy and useful to you. Okay. So here, this is the code that I'm going to do. And here we have written the entire code so that you don't have to worry about it. So we want to, what is it that we want to do? We want to do the character frequency. So all we have to do is we will pull that code from our repository, then go to the repository, pull the data, uh, as in update the data, then go to this folder, and then we execute this. Okay, we execute this. So let this is what, yeah, here we are. And where is the console? This is the console. I go to this folder. All right. Or let me just say, okay, actually I'm lost in the windows. Now it'll be better. So let me just get the data. Let's just get the code from my repository here. Okay, then I say this. All right, so I got the code from this location, and then I can go to this particular folder, and afterwards we could execute this. Okay, now this is our MapReduce job. What it does is it executes this particular logic. It reads data from HDFS and creates the output at this location. And these are the programs that we are giving to it. Please pay attention that we are telling it that we are telling again, let me just show you. Here we are telling that this is the logic that we want to run on top of many machines. And here we're telling that this is where our input data is there. And this is where our output folder should be created. And here we are specifying what are the input and output files. Sorry, this is our logic. This is mapper and this is our reducer. Okay, so we basically all right, we basically executing a map reduce job. I know that 90% of it will not make sense to you right now, but trust me, it would help you. Okay, so it is saying that, let me see what error are we getting here. Okay. All right, let me try again. Okay. So it says the job is not successful because some of the things have failed. Okay. Probably the command is wrong or we have done some kind of mistake somewhere. Okay. So let me just delete this folder and then try again. Hadoop fs dash RMR. Okay. So never mind. So this is how we generally execute the MapReduce job. Okay, so let it it'll finish parallelly, and we will see that later. Now that's what is the MapReduce one. Good. Now I'll show you how does the Spark works. This time it has worked fine, and this Hadoop MapReduce is going to finish parallelly. So it has done the work, saved the results in this folder. We could go to file browser and take a look at it. I'll just sort my folders in HDFS using this. Okay, so here it is. So this is where it has saved the results. All right. Okay. So what it is doing is it is counting the number of characters. Okay. Remember our counting vowels problem. Here we are counting the characters. So you can see that A has occurred how many times, these many times in the input file. Okay, so that's what we wanted to demonstrate, that we can do things like as simple things like counting characters as well as all kind of complex things using MapReduce. Okay, so that was a quick demonstration of MapReduce. Now let me just show you how does Spark look like. I'm not going to go into detailed example. So you can interact with the Spark from here. Okay, if you want to interact with Spark using Python, you can use PySpark. Okay, if you want to interact with Spark using Spark Shell, using Scala, you can launch Spark Shell. Okay, and so on. All right, so that's about Spark. We'll go into probably a little bit more details when we talk about Spark. All right, now there are many things that you could do from the console here in CloudX Lab. Let's say you want to work on R. You can either use R here, or I'll show you how to use R using Jupyter towards the end. Okay, so either you could use R here like this, or let me quit, or you could use some the other notebooks. I'll show you the notebooks later. If you want to work with Python, you could just type Python here. If you want to work with compile Java code, you could do Java code. If you want to work with usually Linux, then you have Linux here. And if you want to work with any other things like C, C++, everything, that all of these tools are available in the lab. Okay, even if you are the lab is same for data scientists as well as data engineers, so that you could do all kinds of experimentations. All right, you have all the tools available in the lab. So that is about the lab. Now, getting back to it. So we talked briefly about MapReduce. We talked very briefly about Spark. We'll go more details about Spark in a while. Now, next thing is a NoSQL data store. What is a NoSQL data store? NoSQL data store is something which is not an SQL, or we can say not only SQL. So essentially, NoSQL data store is a distributed data store. Okay, now a big question that people ask at this point is, when we had a file system like HDFS, why we need a data store? My answer to the question is, when we had the file system on Windows, why did we need a database or Excel sheet? Correct? Why we need a Microsoft Excel or database when we already had the files? Reason is, in files, if you have to record, edit the records, update the records, delete the records, using files, it's really hard. Imagine using files, you are using CSV file and you are deleting a particular record. You will actually have to delete a line, and deleting a line means saving the entire file again. Therefore, handling records is really hard when we deal with files. Okay, so record-based editing was not possible using HDFS. HDFS was good for appending to an existing file, deleting a file, creating a new file, and so on, but not really updating a particular record. Right? So that's why HBase was needed. And HBase design is, again, really friendly if you are trying to tackle the records. Okay, let me just give you a quick view of how does HBase look like in case of CloudX Lab. If you go to data browsers, inside Hue, you will see HBase. Okay. Also, let me just show you here. Okay. Yeah. Also, you can take a look at HBase here directly, as well as you can understand more about NoSQL here. All right. So, and let me just give you a quick view. Okay, looks like something wrong with HBase. Everything is active and up and running. All right, let it show. In the meantime, we could also take a look at HBase using HBase shell. Okay. Okay, using here, we could take a look at the status, or you can also say list. These are the various files that are various tables that are there in HBase. We can also take a look at a particular table, say YouTube here, YouTube table. You could just take a look at this. So you can see that it has so many columns and so many records. All right. So this is how HBase looks like. You could take a look at the HBase inside the course. All right. So that was a quick peek into what HBase is. HBase basically provides you a way to. There's something wrong with the website. Rest is maybe the traffic is there or something. It's the hue probably that's giving the problem, because here we can see the data easily from the shell. Okay, so as you by now must have guessed that most of the work can be done from the console. We can interact with any service from the console. Okay, so it has basically these columns, these are the rows, and so on. Okay, so these are various this table has columns and rows, and this is what it is. Okay, now that was about That was about the HBase. Now going back to HBase, we have, okay, so HBase is nothing but tabular structured storage using many computers. All right. Now, for every work, we cannot keep writing code, right? We can't keep writing MapReduce logic. That's why Hive interface is there. Hive provides you to express your logic in terms of SQL instead of code, and therefore we should be able to interact with most of the system using Hive. Okay, so Hive basically lets you query data in HBase, lets you query data in HDFS using the interface and so on. So Hive is a good tool, very good tool to interact with Hadoop. Using Hive, using Hive server, Hive provides a Hive server as well. Using Hive server, we can present data via Tableau. Tableau would connect to Hive server and present the data. Okay, so any analytics tool, BI tool, or Tableau or any other presentation tool, they generally would connect to Hive server. Hive server will ask Hive to execute things. Hive will ask MapReduce. MapReduce will ask Yarn, and Yarn will talk to the HDFS. So that's how the whole chain of commands, chain of system work. Okay, so let me show you how does Hive look from Hue. If you go here, query editor, and click on Hive, okay, right? So there are so many tables here. Okay, let's say I have a table called U data. I could say select star from U underscore data. So you can see that it has columns and everything. So when we say select star from U data, where and I'm saying U data group by, let's say, this is a movie data. First column means user ID. Second column is movie ID, means this user, 196 user, watched this movie and gave the rating as 3 out of 5 at this time. So this U data represents the ratings given by a user. So now let's say I want to find out the ratings of each movie, okay? Ratings of each movie, and how would I do that? I'll group it by movie ID and say average rating, right? And from U data, and then I say group by movie ID, right? So here under the hood, it is actually executing the MapReduce and giving you the results here. You can see that it's executing on the yarn cluster and getting the work done for you. Okay, so you see that? So the ratings of the movie one is this, and here it is. Okay, if I say order by R, then it'll order the data based on the ratings. Or if I say descending, then it'll basically give us the ratings of the movie which are great. So what we saw just now is we were able to express the MapReduce using SQL. Under the hood, it was basically talking to the MapReduce from here. Okay, so in this diagram, we talk to Hive, Hive talks to MapReduce, MapReduce executes on Yarn, Yarn basically talks to the actual computer and get the work done by reading data from Hadoop file system. Okay, so this table is created in Hive. All right. So these ratings are actually stored in a file. Okay, if you say describe formatted U data. Let's understand where is this table stored. Okay, so you can see that it is stored in file system at this location in this file, this folder. Okay, at this location in this folder. You can go to this location and check it out whether it is there or not. If you go into file browser, so basically this table is actually a file in HDFS and we're querying that file using SQL. That is the magic done by Hive. Okay, so Pig is very much like Hive, just that Pig doesn't have a server. Then we have Mahout. Mahout is a machine learning library that you can use to do various predictions. Okay, internally, Mahout uses MapReduce and so on. And then we have Flume and Scoop. Flume is for importing structured data from Hadoop. Scoop is for exporting unstructured data. Using Scoop. Okay, all right. So that was a quick overview of this. Let me just try to answer some of the questions. And let me just answer. Okay. A question from Sheshu is, what is stored in NoSQL then? So Hive is not really storing anything. Hive is storing, putting the data in HDFS. Okay. So HBase is basically for record manipulation. And as a matter of fact is Hive is kind of trying to compete with HBase. Hive was designed for read-only operations. Hive was designed for read-only operations, but lately Hive has also started providing you record-based editing. All right. But performance of updates and modification in case of HBase will be really high as compared to uh, Hive. So HBase is great for data or record-based updation as compared to Hive. Hive is great for performing the analysis relatively static. Okay. A question is, where can I find some of the free resources? The easiest one is when you log into my lab. Okay. One is go to home page here. Towards the bottom of the screen, you will find a lot of free resources here. Similarly, if you go to my lab, you can see a lot of it inside the here. If you click on learn, CloudX Lab/learn, there you will find a lot of getting started guides. All right. As well as keep a lookout on the blog. We have a very active blog. Okay. As well as we have discussions where people keep on contributing to discussions. Okay. A lot of people keep on contributing to discussions here. So come over to the discussion forum. All right. There people keep on asking questions and helping each other. Feel free to help each other in the cluster, in the discussion forum. Okay, so those are the free resources. You could give it a try. And now coming back to it, so here Flume and Scoop is something that is available as part of the cluster. If you want to interact with Flume or Oozie, uh, Scoop and Oozie, you can just do it from here. Let me exit from here. So you could say Flume, okay, and remaining command line you can pass. Okay, that's how you use Flume. Similarly, Scoop also you can run like this. So it'll show you entire details about Scoop. Okay, so this is Scoop is also available there. Oozie is also available in the same way. Oozie's use case is very much like when you have a big project, you will do many things. Some of the things will be in one component and some will another. And therefore, to basically make a full workflow, it'll be Oozie. Okay. To make a complete workflow, we'll use Oozie. So Here is one such use case that in a typical project of say machine learning, you will first bring the data using Flume, put it in HDFS. From HDFS, you may use Pig or Hive or any other tool. Then you will use Spark MLlib, then you will use Scoop, then you'll use Hadoop, then you'll use Hadoop Spark, and behind AI. Okay. Now we have another tool called Spark. It's a really fast MapReduce, and it is kind of replacing MapReduce for computation, and it is very well integrated with Hadoop. It can run on top of many resource manager, including Yarn, and it can also, if you don't have a resource manager, it comes with its own. It can read data from all kinds of resources, all kinds of places. It provides many libraries for graph processing, for machine learning, for streaming, for SQL kind of processing, and you can use various languages to interact with the Spark. You could use Scala, Python, Java, you could use SparkR, you could use SQL to interact with Spark. Okay, so now this is, if you want to enroll, you can go to our homepage, click on Big Data with Hadoop and Spark and enroll. Now, coming back to your questions, and I'd like to demonstrate some more things here. So you can interact with Spark from here, PySpark or Spark Shell. If you want different versions of Spark, you can go to the user folder, and let's say you want to use this particular version, then inside bin, you will get all kinds of programs. So these are, for this particular version of Spark, let's say I want to interact with Spark using PySpark, using Python for this particular version. So I could use this. Okay. So I'm just trying to demonstrate that all possible versions we have put on our cluster. Okay. All right. All right. So here you could interact with Spark using Spark variable and get anything done from here. This is for interactive analysis or doing the interactive ETL. So anything you do is actually a Python program, and the entry point for Spark is the Spark variable. Okay. So, all right. So using this, you can actually interact with any of the tools. The next tool I want to talk about is Jupyter. Jupyter is the machine is very good for interacting with getting the machine learning work done or getting the Python work done. So if you go to home page and click on say learn Python, introduction to Python. Okay. So you will see these. Okay. Here you will have to do exercises on the right hand side, and this is basically Python notebook. Okay, great. This is basically a Python notebook in which you can write the code. All right, so this is how you can get started with Python. This is a Jupyter notebook in which you can write code and it'll give you the answer and so on, so that you don't have to log into console. Here, this is what I've written. I've written a lot of code here. This is my machine learning work that I've done. Okay, so you could interact with it, and even if you have not signed up for the lab, you can at least attend the Python tutorial. Okay, now there are quite a few questions. I would love to answer those questions now. I have kind of completed the demo. Okay, so those who want to stay back, ask questions, please stay back. I would love to answer your question. That might go a little beyond time, but that's okay. Okay, so a question from Daraz is that how do report tool work application under Hadoop platform. So let me just demonstrate to you. So here that you, let me go back. Okay, so you have Hive, right? So Hive provides Hive server. So from here, if you, let me just draw on sketch. Okay, so Hive comes with something called Hive server. Okay, it has Hive in it. So this is Hive and this is Hive server. Okay, now from the reporting tool, say, let's say Tableau or say BI, I'll just say BIRT, but from here, you will basically make a JDBC connection. We call the JDBC connection from here. Okay, and then send the SQL, and then you will get the results here in the BERT. And here, when you send the SQL, uh, here, okay, it will basically ask Hive to do it, and Hive will ask MapReduce to do it. Okay, Hive will ask MapReduce to do it. MapReduce will ask Yarn to do it. Okay, and Yarn will get the things done using many computers. Okay, using many computers. Okay, so Yarn will do the distribution of this work. This query, this SQL query will be translated into this kind of work. I hope that answers your question. A question from Sagar is that what is the difference between mainframe architecture and Hadoop architecture, as both support batch processing? Most of the mainframe architectures are not really distributed. That's one thing I know for sure, but I'm not an expert on mainframe. I've never used mainframe yet, so I won't be able to comment there. But one thing I know that while Hadoop is all about getting work done using many computers, mainframe is not about getting work done using many computers. Okay. Question from Sachin, which big data architecture is best as per your experience for e-commerce project? So it all depends. It all depends. In case of say a Flipkart, they have their own Hadoop cluster, while in case of Amazon, they have their own different cluster. Okay, so it all depends on various dynamics. Okay. All right. A question from Narcis is that NoSQL and big data. NoSQL is basically providing record-based editing, record-based storage and processing using many computers, while big data is a general term to say that data is big data. Or big data tools are basically tools that do the work based on top of many computers. So NoSQL databases are also big data tools. All right. Now, what architecture is best for e-commerce? I hope I have answered the question, and I've answered the question of Sagar also. Question from Velan is, will it be possible to build a complete big data machine learning project in our Hadoop? Like, how do we do using open source software? Yes. Okay, sorry, I read it Hadoop, but it was laptop. Will it be possible to build a complete big data machine learning project in our laptop, like how we using open source software? So theoretically, yes, but since the entire idea is to use many computers, the learning is always limited using single computer because RAM limitations are there, and the experience is different. Therefore, if you want to learn distributed computing, it's better to be learned using many computers. All right, but you can definitely do the POC, proof of concept. A question from Radhakrishnan, do we have access to CloudX Lab sandbox environment? Of course, you can just sign up there and you'll get the access immediately. Okay, if you are joining the course, you'll get 3 months free for the CloudX Lab sandbox environment. Okay, now, question from Abhishek, can I get your blogs for knowing your journey in big data from the beginning? Um, so yes, we started, as in I worked with Amazon, I worked with Isha, worked with my own startup called Tbits Global, where we built big data platforms, as in document management using these distributed systems. And then we started a company called No Big Data, where our students were facing a lot of challenges with respect to installation. So we set up the lab for all the students, and that became the differentiator in the industry. Okay. Now, a question from Satyam is, what does searching and indexing takes place in Hadoop? In Hadoop, basically, the searching and indexing is not really a great solution here, but you can definitely create your indexes in Hadoop, but it would be better done using, say, Solar or other systems. Okay, it's better to do that using other systems. So Hadoop is great for batch processing. A question from R. Ganesh is, so Yarn is a place where we do development for processing data. No, we don't interact with Yarn. It's these frameworks like Spark and MapReduce which interact with Yarn. We code against either MapReduce or Hive or Spark. Okay. Question is, what is the easiest method of understanding MapReduce? The easiest method is to think of MapReduce as built of two things, where the distribution like this is happening. This is map phase, this is map phase, this is map phase, this is map phase. And the work from all these computers is gathered using the reduce phase. This is second is reduce phase. Okay. The best way to understand map reduce the other way is to look at the group by. Okay. So map reduce is nothing but a big group by. Okay. Group by as in we define the way we define grouping. We are grouping the data based on this. In the map, we define the key as this, and it will group the data. Here we are saying average, but reduce means we'll define this function by ourselves. Okay, so that's how probably group by query is a better example of understanding map reduce. Okay. A question is, what is Kafka? Kafka is a message queue, or you can say publisher subscriber kind of a model where people keep on writing to the queue and other people keep on reading from the queue. In an organization, if many services need to inform other services about various interesting events, they will use a queue like Kafka or any other message queue. Okay. The other alternatives of Kafka is SQS and so on. Question from Ramya, what tool can we use if there is a need to integrate structured and unstructured data for business use case? You can actually use MapReduce or Hive because Hive lets you handle both of them. Okay. Similarly, you could also use the Hadoop streaming and so on. A question is any support on project once you enroll to CloudX Lab? Yes, we do. Okay, we would help you with the project, and most of the project evaluation is automated, so you will get instant feedback whether you're doing good or not. Okay. Question from Jayant, traditional Hadoop versus Amazon Redshift stack, which one is better? If you are handling transactional data or if you are handling a lot of writes, then Amazon Redshift is great. If you are doing the batch processing and your computation is intensive, then Hadoop will be far more cheaper. Okay, so yes. A question from Daraz is, as end-to-end, would we need to learn software or application for get Hadoop job? So you will have to learn both the software as well as application to get the Hadoop job. Okay, but my suggestion would be that you should know how to get some work done, at least using Hive. Okay, at least using Hive. That'll be the minimum thing that you should be able to achieve. That's why we have made the Hive project as free so that everybody can attempt it. All right. Question from Velen is, can we use VMs to simulate distributed computing? You definitely can do that, by installing multiple VMs and so on. Okay, you can definitely do that, but you would not get the proper experience because it's the same hard disk that is being read, and you will always see that the time taken is increasing rather than decreasing in case of distributed computing. Okay. A question from Sheshu is, how does typical architecture looks like in terms of machines, master slaves, and the solutions installed on them? So the CloudX type environment is probably the typical and the smallest cluster you could see. Okay, there's a basically representation of how it happened in Mobi and other places. Okay, that is basically the entire cluster inspired from the production environment. All right. So a question is, can I build algorithms based on big data for e-commerce client to track their sales? Yes, you can do that. You can definitely write your Python Spark job or MapReduce job to do that. Okay. Ramya's question is, what tool can we use if there is a need to integrate data from structured and unstructured data sources stored in HDFS? I think I've answered that. All right. Was able to answer the question. The question from Ramya is, what's the difference between Hortonworks and Cloudera-based Hadoop instance? This diagram that I talked about earlier basically touches upon that. So you have Cloudera, you have Hortonworks. Both have common as Apache Hadoop, right? That's open source. Then Hortonworks have extra tool called Ambari. Then you have Hue, Cloudera Manager, and there is something called Impala from Cloudera, which is basically under the hood optimization for Hive and so on. Okay. All right. I hope that answers your question. Uh, a question from Sachin, how to integrate Docker with big data, or what exactly Docker fits in big data ecosystem? So Docker basically is quickest way of virtualization. So basically the way Yarn is doing things is similar to what Docker will do. So Docker essentially isn't required in case of big data in general. Okay, but Docker can be used in other use cases where you want to isolate one user from another, one and so on. But in case of Hadoop, that job of Docker is kind of done by Yarn. Okay, which is the best landscape if we use RDBMS database to HDFS? If we use RDBMS database to HDFS, um, it's hard to define best one. All I've learned is that you always use a hybrid approach. You always use a hybrid approach. You keep the highly transactional data or highly relational data is still in the RDBMS, while most of the other data in which you need to do quick updates is in the HBase. If for rest of the batch processing a static data, we put it in HDFS and so on. Okay. A question from Sachin is, where Docker fits in big data ecosystem? Docker basically is kind of um, not part of the ecosystem of Hadoop. And the only thing I can think of is if we want to launch many clients parallelly of Hadoop, then we can use Docker. Okay, so a question from William. So learning Hadoop big data is more learning tool, admin architecture tasks, while machine learning is more logic programming part. Here also, when you do the computation like Spark, then you will have to write logic. Okay, you will have to write logic, but largely on a very from a very far away. If you look at from generalization perspective, you are kind of right that if you have to do more of data structures, this and that, then machine learning requires a lot of data structures and understanding of programming, while The Hadoop is requires a bit of programming knowledge, but you can happily get most of the work done using SQL and so on. Okay. Next question from Sheshu is, appreciate if you can prepare the index of components under Big Data umbrella and share. Yes, so I have prepared, we have the one which is there for the Hadoop ecosystem, but not the other ones. Okay, other ones will become like too crowded actually. Okay, we'll see if we can do that. A question from Daraz is, tell something about certification under Hadoop Big Data. Is it required? So it is actually very subjective thing. So my understanding is that one must learn to solve problem using Hadoop and Spark, because companies which are serious about hiring engineers, they will ask the questions, they will interview properly, right? The companies who don't have the capability of interviewing on big data, they will generally resort to the certificate. So though certificate could be great, but work with respect to solving problems. All right. That would be my suggestion. Question from Abhishek. I'm a Teradata DBA by profession and would like to enter the big data field. I have about 10 years of DB experience. What would you recommend for career path? So see, this is a very interesting question. Thank you for asking this question. So a DBA, a typical DBA has a big role. DBA is not only a sysadmin. DBA does a lot of engineering work. So the closest would be to go with the data engineer kind of a role. That's the one that fits the best for DBA. Okay, so I would strongly recommend that you focus on the data engineer kind of a career. That'll be the easiest to move on to. That'll be the easiest upgrade. Okay, so and then you can further move on to data scientist kind of a role. All right. Great set of questions. I thoroughly enjoyed your questions. Feel free to leave the feedback. I look forward to see you in my usual classes or on the lab. Okay. So thank you, everyone. I look forward to see you. All right. Bye-bye. Have a good day. Okay. Wonderful set of questions. Keep the questions coming. As in any session that you attend, ask as many questions as possible. That's how you will learn. Hi, Shiv. Go ahead, please. Okay. So you can actually go ahead with the self-paced course if you're interested. Self-paced course is really small, really easy. And in case you want to upgrade to the full-fledged, the live instructor-led, you can upgrade later. Okay. Uh, all right. So Shiv, feel free to write to me at reaches@CloudXLab, and then we can schedule a one-on-one discussion if you want to have. All right. A question from Daraz is that I would like to again another demo. That's completely okay. Just reach out to us at reaches@CloudXLab. Okay. And I generally see all the emails. So, okay. But in case I'm not able to respond, one of my teammates will respond. So, all right. A question from Jamilio is that um, I'm interested in CloudX Lab for final year project. What kind of support can I get for you? Okay, just can you write in detail to reach us at CloudX Lab. I would love to understand and have a further discussion. Okay, I would love to have a further discussion. So this is the email ID that you see here at the bottom of the screen. A question is, Ambari and Impala are used to access Hadoop cluster. Ambari is used for Hadoop cluster, but Impala is more like Hive optimization under the hood. Okay. All right. So great set of questions. Keep the questions coming. Come over to our discussion forum if you have technical questions. If you have something related to want to discuss a particular thing, then reach out to us at Reach Us. If you have a technical, a general question, come over to discussion forum. That's very active forum which we have. Okay. All right, Shiv. Great. And all right. Thank you, Shiv. We will uh, okay, I'll just send you my calendar so that you can schedule a discussion and then we can have it. Okay, wonderful set of questions. I thoroughly enjoyed answering your questions. Feel free to reach out to us. If you want to write about us on your blog or in Quora, feel free to do that. And okay, great. Thank you, everyone. Have a great day. Bye-bye. Okay. All right. So wonderful set of questions. Have a great day. Feel free to write about us on Twitter, Quora, or whatever social media do you use. And feel free to reach out if you have any questions. Okay. I hope today's session was useful for you. And that's the general objective of the session.